When we look up at the night sky, we see this incredible universe of stars and galaxies. But what if there's more? What if there are entire worlds out there made of stuff we literally can't see or even imagine? Could there be planets, stars, whole galaxies built from dark matter or its mirror image, antimatter?
Okay, before we dive in, let's just get a little bit of cosmic perspective. Everything we've ever seen, right? Every star, every planet, you, me, all of it makes up less than 5% of the known universe. That's it. The rest, the vast majority, is a mix of two of the biggest mysteries out there, dark matter and dark energy.
So this just begs a massive question, right, doesn't it? If the stuff we're made of is such a tiny sliver of the pie, what's going on with the other 95%? Could it be out there building its own cosmic structures, totally separate from ours? Well, let's find out.
We've got two main suspects in our little cosmic detective story. First, there's the famously shy and elusive dark matter. And second, we've got matter's explosive twin, antimatter. Let's dig into the evidence for each one.
It's really important we get to know these two. Think of dark matter as like a cosmic ghost. It's got gravity, we know that, but it doesn't seem to interact with light or normal matter in any other way. It's just there. Antimatter, on the other hand, is almost exactly like the matter we know and love, but it has an opposite charge. But here's the kicker. If a particle of matter and a particle of antimatter ever meet, they completely annihilate each other in a flash of pure energy. Boom. All right, first up to the plate, dark matter. Now, we know it forms these gigantic halos around galaxies. In fact, our own galaxy probably wouldn't even exist without it. So why doesn't it just go all the way? Why can't it form its own stars and planets? The answer actually lies in a really simple but profound property. A better name for dark matter might honestly be transparent matter. Because it doesn't interact with light, it has no way to get rid of energy. It can't radiate heat away into space, and that inability to cool down, well, that's the ultimate deal breaker. Think for a second about how a normal star, like our sun, gets made. Gravity pulls a huge cloud of gas together. As it gets squeezed, it heats up a lot. But, and this is the crucial part, it radiates that heat away as light. This cooling process is what allows gravity to win the fight, crushing that cloud down into a super dense, fiery star.
And that is the problem. Dark matter gets stuck. Gravity can pull it together, sure, but because it can't radiate away energy and cool off, it can never collapse into dense little objects like stars or planets. It's just doomed to be this huge, diffuse, fluffy cloud forever. So the verdict on dark matter, planets, and stars? It's a no. Case closed on that one.
Okay, now for our second suspect, antimatter. And this case, this one's a lot trickier. Because if there are entire antimatter galaxies out there, how in the world would we ever find them? This is the first big hurdle for us. Let's say we point a telescope at an anti-star. Would we see anything weird? Would its light just scream, "Hey, I'm made of antimatter"? The answer, and this is pretty wild, is no. An anti-star would shine with the exact same kind of light as a regular star. Scientists have actually made anti-hydrogen atoms at CERN and confirmed that their light spectrum is a perfect mirror image of normal hydrogen. So yeah, we can't just spot them by looking. Okay, so if an antimatter galaxy is basically a perfect imposter, how do we unmask it? We can't trust our eyes. We need to look for a different kind of clue, some kind of hidden signature. And here is that clue. It turns out the universe has a kind of secret tripwire. That vast, empty space between galaxies, it isn't truly empty. It's filled with this super thin soup of normal matter. We're talking like 1 atom per cubic meter. It's not much, but believe me, it's enough. And that tripwire leads us straight to our smoking gun. When a particle of that intergalactic gas bumps into a particle of antimatter, they annihilate. And that explosion produces a very specific burst of high-energy light called gamma rays. This isn't just any old light. It's the unique, unmistakable fingerprint of annihilation. So here's the key takeaway. If a whole galaxy made of antimatter was just floating out there, its border would basically be a cosmic war zone. That intergalactic gas would constantly be running into it, creating this steady, bright glow of gamma rays. We should be able to see a shimmering halo of annihilation light around any big antimatter structure in the universe. So for decades, astronomers have been scanning the skies, searching for exactly this gamma ray glow. And the results? A big old nothing. Zip.
absolutely no sign of these massive matter-antimatter boundaries. And based on that overwhelming lack of evidence, the scientific consensus was pretty clear. There are no large antimatter regions in our observable universe. Case closed. Or maybe not.
Right when the case seemed totally shut, a surprising new piece of evidence popped up, and it suggests that maybe, just maybe, we were looking for the wrong thing entirely. What if antimatter isn't in some far-off galaxy, but it's hiding right here, in our own Milky Way?
14. In 2021, that's the number that completely reopened the case. See, an analysis of data from the Fermi Gamma Ray Space Telescope found 14 really peculiar points of light. They're giving off gamma rays with energies that are a dead ringer for that annihilation signature we talked about. The wild idea is that these could be individual antistars right here in our galaxy, and we're seeing them annihilate as normal gas and dust falls onto their surface. Now, we've got to be super clear, this is a preliminary finding. It needs a lot more work to be confirmed.
But let's just say it's true for a second. How common could they be? Well, the study came up with two possibilities. If these antistars are hiding out in the thick, gassy disk of our galaxy, they'd be incredibly rare, like 1 for every 400,000 normal stars. But if they're lurking out in the sparse halo outside the disk, they could be shockingly common. We're talking as many as 1 antistar for every 10 normal stars out there. Okay, this potential discovery is absolutely thrilling, but let's zoom out, because it doesn't actually change the bigger picture. In fact, it kind of points us toward an even deeper, more fundamental mystery at the very heart of cosmology.
Whether there are 14 antistars out there or none at all, one fact remains completely unshaken. Our universe is, for all intents and purposes, made of matter. There's this profound, unbelievable imbalance. Antimatter, if it exists at all, is a cosmic fugitive, just vastly outnumbered and on the run. And that is the ultimate puzzle. According to our best theories, the Big Bang should have created perfect, equal amounts of matter and antimatter. If that had actually happened, they would have all just annihilated each other, leaving behind a universe with nothing in it but light. So why are we here? Why is there anything at all? Why did matter win? Where did all the antimatter go? You know, this question of cosmic imbalance is truly one of the biggest unsolved mysteries in all of science. Our search for antimatter worlds didn't really close a case. It just blew the door open to a much, much larger one. It's an amazing reminder that for everything we've discovered, the universe's greatest secrets might still be hiding in plain sight, just waiting for us to ask the right question.